solar innovation group. So our activities are focusing on the solar field, manufacturing technology and process development for the photovoltaic energy, renewable energy production. Enel, as you said before, is a very big company located worldwide. Is one of the biggest network operator in the world of the energy production. And Enel Green Power specifically is the company inside the Enel Group that is owning all the projects related to the renewable energies. In this context, EGP is one of the world's largest player in the renewable production. And inside this structure, there are present some innovation teams who are focusing on the technology development of the different branches of the renewables energies. So from wind to geothermal to solar, as in my case, my group, and all the other renewable energies. In this frame, I will focus on what we are doing specifically in Italy, in Sicily. There is a very big hub in Catania dedicated to the solar energy technology development and production. So first of all, I would like to present you a very short video in which we will show what we are doing specifically in EGP Catania. So I will share it.
There should also be the possibility to share the sound, but I don't know if you have any sound.
Yes, I see here. Let's try if it's shared. Just 1 second. Okay, now yes. Thank you.
Yeah.
So that's a part of what we are doing in EGP Catania on the solar technology development. I will come back in some minutes on what we are doing specifically in Catania, but first of all, I would like to show you share with you some details on what is the photovoltaic and the solar and solar technology. As most of the audience will know, the photovoltaic device is composed by some materials, specifically some semiconductors, that are able to transform the light coming from the sun into energy. As you can see in this picture, the sunlight can go to this material that is a solar cell, and it will absorb the light and will generate some electron-hole pairs. These electron-hole pairs are the real energies, the electrical energy. So we can think as an electrical generator, this semiconductor is an electrical generator. The solar cell must have some other components to work, because we need to extract these electrons from the generator. So it is composed by many other parts that are many other layers that are performing the work to separate the charge and then extract this charge from the generator itself. And this requires to perform some processes to allow to extract from the silicon or from other semiconductor material the charges. Basically, solar cell is a diode, PN diode, with some special design that allow us to perform this kind of extraction. We have different kinds of solar cells. The most diffused in the world is the monocrystalline one, in which the main base is a crystalline silicon wafer that is functioning as an electrical generator, and in which we are processing it, adding some coating and passivation layers that are acting in the phase to extract these charges. There are many other kinds of solar cells, as you can see in this picture, such as some thin film, in which the thin film could be even a silicon-based amorphous film, or another different kinds of silicon films like CIGS, in which we can have the different material than silicon, as for example, complex of indium, gallium, selenide, cadmium, tellurides, and so on. A new emerging solar cell technology is called heterojunction technology, in which we are combining two different generators of electricity, the crystalline silicon with the amorphous silicon. And in this way, we are able to absorb much light from the sun that is coming on the solar cell itself, because with this technology we have the maximum extraction of the red part of the sunlight and the blue part of the sunlight. This kind of technology is the one that is the main focus that was focused by EGP, and is the base of what we have in Catania as a manufacturing fab. Why we have chosen this kind of technology? Not only for the higher efficiency that allow us today to go in production with efficiency that are over the 23%, that are higher with respect to the standard manufacturing technologies that are present in the photovoltaic world today, but is also a more simpler technology that requires less steps of production. So we can combine a higher efficiency with a simpler process. And this is obviously good for a manufacturing site like the one in IGP. Here we come back to what we have seen in the video. The activities of IGP in Catania. We have two main sites. The one on the left that you have seen in the video is the Trisan Fab, called the Sun manufacturing site, in which we are producing heterojunction glass-glass bifacial modules, basing on the technology heterojunction that I have presented in the slide before. On the left picture, you can see the hub lab of IGP, in which we are performing the reliability and efficiency testing of the solar technologies. Obviously, the hub lab is not only dedicated to the heterojunction production of the Trisan, IGP Trisan, but is a full lab that is performing research activities and also testing activities on all the possible technologies. IGP was started as a production of thin film technology photovoltaics, but in 2019 was fully converted to be the first European PV cell and module manufacturing site using heterojunction technology, and has obtained very outstanding results in 2020, in which we have the possibility to certify with an external lab our technology, and reaching the outstanding result of 24.6% of efficiency. What we are doing in IGP Trisan, we are developing many the technology and of the silicon heterojunction, and developing some research and innovation activities on all the layers that you can see in the picture of the silicon heterojunction. So new experiments on material and processes and process development on the amorphous deposition, on the layer of the transparent oxide contacts, on the metallization, and so on. I would like to spend 5 minutes now to show to all the audience what are the possible research fields and also collaboration fields that we can have in Trisan. This is a very short sketch of what is the production process of the cell. You can see that we have many processes that I will show in the next slides more in details. The first big process that we use in the cell manufacturing is a wet etching process, in which we have two phases. One is an alkaline etch that is used to smooth the surface and reduce the defects of the wafer. The wafer, as I said before, is a crystalline silicon N-type doped wafer, and in which we are producing also some texturization using this wet etching, alkaline wet etching, to produce some small pyramids on the buff surface of the wafer. Why I'm mentioning both sides? Because our technology is a native bifacial technology, so allow us to extract energy both from the light that is coming on the front of the cell, the one that is exposed to the sun, but also from the back that could take the reflection or the diffused light that are coming on the back of the module itself. We have some activities on innovation on these steps, and also on the second part, in that this mostly used the acid wet etching process to clean and avoid to have the oxide formation on the surfaces of the wafer. A second very important step of process is the deposition through plasma-enhanced chemical vapor deposition of the amorphous layer on the top of the crystalline silicon wafer. In this case, it's very important to have a very clean process that allows us to passivate with amorphous, intrinsic, and doped layers, very thin layers, the substrates of crystalline silicon. There are still very good possibilities to improve all these processes in the manufacturing. So some big efforts are in this period pointed out in the developing of the similar process. This process is important both because it allows us to passivate the surface of the wafer, avoiding the transfer of contamination to the silicon wafer, and both to create also the junction between the crystalline silicon and the junction that allow us to extract the carriers and so the electricity. The following big process step is the deposition of the transparent conductive oxide. We use in this case some sputter, so physical vapor deposition processes. The importance of this layer is that it allows to distribute all the carriers, so the charge that are extracted from the junction that we have created with the amorphous deposition, the crystalline wafer, and allowing in the same time to the light that are coming on the cell to pass through it and going to the silicon. So we have a process that is in this case creating a layer that should be both conductive optically and also electrically, and this is a tough process to be performed. The last big process is the metallization one. In this case, we are using some, we are scribing some, in general, silver patterns on the surfaces of the cell precursor, allowing us to connect the external circuits to the cell and allowing to extract the energy and transport them externally to the cell and then externally to the module. These are a very, very quick sketch of what we are performing as manufacturing processes in the Trisan fab. This allows also our audience to evaluate if there are some interest in performing some internship in the manufacturing environment, or also in the research environment for the development of this technology. But EGP in Catania is not only offering this kind of possibility. We have also this lab and hub located very near to Trisan, 1 kilometer near to the Trisan fab, manufacturing fab. That is a site that is performing the activities of characterizing the technologies, the solar technologies, and also measuring both the reliability and the performance in indoor mode. So with some instruments that are allowing to simulate the sunlight and having some standard condition to measure and compare all the photovoltaic technologies, but also in outdoor. And in this case, we have some small plants that are directly exposed to the environment, to the sun, to evaluate the real efficiency and reliability in weather condition. So you can have the possibility, in this case, to cooperate in the development of measurement protocols, development of standard protocols, and so on, and to develop also a new kind of standard that allow us to evaluate and simulate and also demonstrate that simulator are working using the real weather condition and not simulated one in the labs. So that's all the scheme of what we are doing in EGP with focus of Catania activities. So if there are some questions or so other, I'm available. We have some minutes, I think.
Yeah, thank you, Claudio Colletti, for this very comprehensive talk about solar cells. As I'm a physicist, I'm very interested in this, and there was some for me very familiar. Maybe not all from our audience were so familiar with this solar cell production. So it was quite interesting. Yeah, I would again encourage you to ask any question, either in the chat, I don't see it at the moment, or directly via the video conference. And maybe again, I want to mention, Franziska posted this again some minutes ago. I want to again mention our internship portal, because you, Claudio, you mentioned it also, doing internship. We have a portal from UNIS. That means that more or less all partners have collected the companies who are offering internships in their area around or in their country. And I think that Enel surely is also offering the internships.
EGP is scheduling to propose some internship for 2022. Mainly focusing on physics, the master degrees, also chemistry, obviously. And I had also some possibility also in engineering, since in the manufacturing fab we have also some highly automated equipments and so on. So also engineering will be a probable profile.
Exactly. Yeah, that would be my second question. What fields you are interested in, fields of study? So yeah, I could imagine physics, chemistry, of course, but also product engineering and automatization. I think it's also a big topic for you, and maybe also business science. I don't know.
Exactly. No, we are focused more on technology development. So automation engineers, you say, the physics, both on modeling and on process, and also chemistry in the process development and material development also.
Yeah, right. So I think that yeah, again, if you are interested in, you from the audience now, interested in doing internships, look into the internship portal. You will find internships from your company, Enel and EGP, but not only. There are also in other countries, of course, all countries where UNIS is. We have some internship offers there. Yeah, so I don't see any more questions. So that means that I would thank you again for your presentation of Enel, Claudio Colletti.
Thank you.
And yeah, and I would move on, because in the next presentation we have two companies, so we have to a little bit hurry. to get it in half an hour. The first one would be ENGIE, Electrabel, and Laborelec. Oh, I don't know if I pronounce it right.
Laborelec.
Laborelec, but I hear a voice from the background, so I know that our speaker is already present.
Yes, thank you.
Yeah, François Boisselot. So your company is actually from Belgium, right?
Yes.
Not only.
Not only.
Electrabel, I know it. I have been in Brussels, and I think that they are a company. They are supplying, I don't know, electricity and internet and something. So I know this company from my time in Brussels, and I'm keen on your presentation. Like I told you, we have to keep it in this 15 minutes. Hopefully, we can manage it. Also, the questions, because we have two companies in the slot. So the floor is yours for your presentation.
Thanks a lot, Patrick. I believe my colleague Jean-Pierre will show the slide.
I'll share the slides. Normally,
wonderful.
It work. I don't know if you see the screen now. Do you see it?
Yes, we see the screen. Thank you.
In presentation mode?
Not yet. Not on
it?
my side, at least.
Yeah, it's not presentation mode.
Is it now in presentation mode?
Yes. Thanks a lot, Jean-Pierre.
This is a miracle.
So thanks a lot for the invitation, Patrick. So my colleague Jean-Pierre and I were very happy to be here to introduce, let's say, our company, ENGIE. So I'm François Boisselot. I'm a chief economist for ENGIE in Benelux, and Jean-Pierre will introduce himself. He's part of Laborelec. So the idea here is really very quickly, in 2 minutes on my side, to introduce the ENGIE group. And then Jean-Pierre will dig into one sub-element of ENGIE and discuss what Laborelec is doing, which could be of interest for our public today. So talking about ENGIE, so if we look at ENGIE, we are quite a big company. It's not only Electrabel. I will come back to the link between Electrabel and ENGIE. So when we look at what we do today as ENGIE, we are building the low carbon energy system of tomorrow. So we are really focusing on low carbon, on renewables, and I will come back on that. So really our enemy, let's say, is CO2 and carbon, and we are trying as a utility to work on this and build, let's say, this future. You can move to the next slide, Jean-Pierre. So what do we do? What are our core? We have 4 core activities, and you will see we have a bit more of this, but if you have to think of ENGIE as a whole, we have 4 core activities. The first one is very easy to understand. It's renewables. So we are a developer of renewables and operator of renewables in many places around the world. Here, this is a corporate slide that shows where we are number 1. So we see that we are number 1 in France. In Belgium, we are also number 1. It depends how you count. What is funny in this business that you have always 2 or 3 number 1, because then people look only at PV and they are number 1 of PVs. And if some people look at PV and wind and they are number 1, in our case, we are number 1 if you look at biomass, wind and PV. Doesn't matter. So we are active in many countries and have a pretty significant position in renewables. We also, for instance, are one of the first players who invested in floating wind farms, which are quite an interesting concept to increase the capacity for renewable development and wind especially, but also we do it for floating PV. So our second activity is network. So network, we are mainly an actor in gas network in France and in Brazil, where we have our historical position. So we, let's say, carry gas in different places. We are operator of this network, and we try to use gas as a key element of the energy transition in this phase towards carbon neutrality. And it's important to have this concept of transition in mind, because we are not going in one night to move from a system where we have a lot of fossil fuel to a totally decarbonized system. We have a transition. This transition started many years ago. If I just look at Belgium, 20 years ago, we almost had no renewable at all in the fuel mix of Belgium. And today, or actually, if you look at just the figures of last year, almost 20% of our electricity, and electricity is just a sub-part of the total energy consumption, about 20% of our electricity came from renewable last year. By 2030, Belgium is targeting almost 50% of renewables. It depends on the scenario. And until 2050, the ambition is really to be with a very large share of renewable, 100% for some under some scenarios, 90% under some scenario. But you see that within 50 years, we will move from 0 to a system highly dominated by renewables. Our third activity is what we call energy solution. So that's basically a solution you bring, for instance, to customers. So we are, for instance, number one in cooling network, where you can help people with air conditioning, for instance, and you have a network where you will bring this cooling to different customers. We also supply hydrogen and CNG. It's not GNG, it's CNG. And we're also a player in energy efficiency solution, where we will assist some customer in improving their efficiency. And last but not least, what is well known in Belgium, actually you see this is a corporate presentation and you see that Belgium is mentioned here, but we could mention it also for renewables and for energy solution. We don't have any network in Belgium. Actually, it's forbidden by laws, and unbundling is very strong in Belgium for networks, but in some other country we do. It's really thermal and energy supply. So we are historically a large player for producing electricity with all type of technologies. So in Belgium, we are well known for the nuclear power plant. At least we are well known until 2025, because as of next year, we start the nuclear phase out, and by 25, there will be no more nuclear in Belgium. We also have gas plant, of course, in Belgium. We have renewable, I already mentioned them. You can also think of hydro, that sometimes we put here in thermal or we put it renewable, depends or we are organized country by country. We also historically had some coal plant, and we are starting to stop all those plants, and we supply customers. So I hope that everyone here has a ENGIE contract for their supply of gas electricity, because our electricity and our gas is way better than the one of our competitors. If you had moved to the next slide, Jean-Pierre. So we are well known in Belgium, but we are definitely an international player. So if you look at the last year, we have about 170,000 employees. It's very easy for Belgium. It's 17,000. So 10% of the employee of ENGIE worldwide are based in Belgium. So you see that Belgium is definitely a big country for ENGIE. You see a bit the split of our revenues per region. So France is historically a very important country, where ENGIE is a result of a couple of merger and acquisition. And for instance, Gaz de France is an important element that was at the roots of the creation of ENGIE. You see rest of Europe, where Belgium is part of, which is also very significant. And you see that we are active in several places around the world, where we are developing different positions. I mentioned Brazil, which is a very important market for ENGIE. North America is also very important. We have been one of the first players in the Middle East developing new power plant, and we are also starting new activities in Asia already since a couple of years. And my last slide before I give the floor to Jean-Pierre, if you look at ENGIE in Belgium, so we are on renewables, very active on all type of renewables. And if you follow the news in Belgium, last week, the federal government announced new ambition for wind offshore. This is definitely a good news for Belgium, and this is definitely an opportunity that we already had under our radar, but we will look at it extremely carefully. Energy solution, we are working with several companies here in Belgium, big companies, small companies, to help them to develop actually to reduce their CO2 footprint, investing on their side, for instance, in a different solution. Thermal and supply, we are a supplier for almost 50% of customers in Belgium, from B2C to B2B. We are also active in the famous CRM. Some people in Belgium may have heard of it, as a capacity remuneration mechanism. We made an offer for 2 new power plants at the beginning of this month. And at the end of this month, we will know whether we will build 2 new power plants. We are confident that our projects are really good. We will see if our competitors have better projects, but we will build this plant if we are selected to ensure security of supply in Belgium. And nuclear, as I mentioned, this is historically a very big activity. If you look at the 40 last year, basically nuclear represented something like 50% and even more at the beginning of the electricity production in Belgium. This will continue for the years to come until 2025, but the nuclear phase out start next year. So we'll close the first plant next year, and we will then do the dismantling, which is a gigantic project where you will have to dismantle those power plants. ENGIE is way more than that. We have also other activities, and some people may have heard of Tri-Table Engineering. We have R&D, and Jean-Pierre will have mentioned it. We also have a global portfolio management and trading activities that covers all those solutions. But I will stop here, and I will give the floor to Jean-Pierre that can dig into some specific element of Laborelec in terms of R&D.
Thank you, François. Yes,
Yeah.
we thought it would be interesting to present also the R&D side of the ENGIE group in a couple of slides. So I will make it very short, Patrick, don't worry.
Yeah. That's unfortunately also my task. We only have 5 minutes.
Yeah, I know. So well, it's just a couple of slides. ENGIE Laborelec is one of the 2 main R&D centers of the ENGIE group. And it is very much focused, for historical reason, on the electrical power value chain. And we have a global presence. Laborelec is a company on its own. It's an affiliate entity within the ENGIE group. And we have an main office in Brussels. And we have branch office in France, Netherlands, Germany, Chile, and Middle East. What is characteristic for Laborelec is that as an R&D and competence center within a large group, we do have a quite highly skilled workforce. We have quite a lot of PhD engineers, specialized technicians, which is excellent for the relationship with universities and so on. We do 3 types of activities. We do R&D, we do R&D projects, but we also do servicing, consultancy with the specialized expertise we have. We sell that consultancy as a service for customers. Of course, a large part of our customers lies within the ENGIE group, but we do also serve in expertise customers outside of the ENGIE group. And beside that, we have also some development. We can sell some product, physical or software products. Now, our main assets is our knowledge. So we base our expertise, we base our activities on the expert knowledge. We have also a quite excellent knowledge in the operational aspects of our customers. We know how a power plant is, how it is operated. We know also how industrial aspects behind in our customers are operated. And we have a very strong capabilities in measurements. So we are not staying behind our computer. We are going on site. We measure stuff. We go on site and we measure the stuff. So this is the list of competencies that we manage. I will not go through this because it's an exhaustive list of all the domains in which we manage, but just remember that it is covering the complete value chain on the electrical power technology. So you will find stuff like water, biology, materials technology, Internet of Things. This sort of stuff are heavily developed at Laborelec. And these are the 6 main, and this is my last slide, the 6 main domains in which we focus today our R&D activities. You will look at this, but you will recognize, of course, all these topics are strongly focused on the energy transition. And to conclude, I would like to say something about what type of people we'd like to recruit. And we like to recruit people which have this sense of multidisciplinarity. We like to have people that like to have a certain level of skill, so expertise, that like expertise. And we like also to recruit people that have project-oriented mindset, knowing what the start and the end of a project is, what is a budget, what is a result. These are really stuff we like to have. And people that are able to deal with uncertainties, managing the uncertainties. And finally, and that will be my last words, people that are genuinely convinced by the energy transition necessity. I finished there.
Thank you, Jean-Pierre Koestermann, for your short presentation. We are perfectly on time. And I would ask if there's any question. I don't see it in a chat or something like this. Would ask you to ask the questions. Yeah, so as I understood right, this Laborelec is, so to say, the research and development unit of ENGIE. Can one say so? Or,
yeah, perfectly.
Okay, okay. Huh?
It is
so
the
that is
R&D. It's one of the two main R&D centers of the ENGIE group.
Oh, okay, okay. So that is somehow the natural contact point for us universities to your company. So so that's quite right that we have you here presenting all this.
And what's interesting is that there is a sort of porosity between the ENGIE group and the Laborelec or the other research centers. People are often starting a career somewhere and diffuse in the other entities. So it is a very natural stuff.
I mean, that is an experiment. It's not a new experiment. What we are starting with UNIS, yeah. So cooperation with companies, not only national but also international. That is a little bit tricky. It's easier for great companies who are anyhow international oriented. But we also had today some very small startups founded in 2018. So that is more an experiment there, and we were also somehow interested in how it works with the companies. I think that is a special a point in UNIS. Yeah, we are one of 41 European universities, but we have focused on this interchange between the academic and the non-academic sector. What is very important, what is in line with all the European demands, and I think that's quite interesting. But I should not talk that much. Maybe there are some other questions. But I don't see any question. So as we have a second presentation in that slot, I would thank you again.
You're welcome.
From Eni, Francois, and
you're welcome.
Jean-Pierre for the presentation. And I would hand over to the presentation of Materia Nova, also from Mons, I think, or from Belgium at least. And Martine Bouvet, I hope I speak your name right. Sorry.
Hello everyone.
Hello.
I'm Martine Bouvet. Yes, hello. Do you hear me? Yes.
Yes, we can hear you. Thank you very much. And I would just briefly give you the floor, the virtual floor, for your presentation.
So first of all, do you see my screen?
At the moment, not. I think there's a green button below share screen. Yeah, now it works. Yeah, very fine. We see it. Thank you.
Okay, fine. So first of all, I'm presenting myself. I'm Martine Bouvet. I'm working since 2 years at Materia Nova, and I am a business engineer. I spent most of my life in business development and marketing role. So I'm going to present to you today Materia Nova and our activities. So Materia Nova is part of UMON's innovation network, but it's an independent research center. So we have 85 experts. We are equipped with large platform of advanced equipments. We are a major player in public call for project, and we support industrial from design phase to industrialization. Last year, we celebrated our 20 years of existence, and in the past 5 years, we have completed no less than 200 projects. So Thanks to our link and proximity with the University of Mons, our team ensure the right matching between the fundamental research, which is more in the university, and the market needs. And thus, we optimize the transfer of research to the industrial world. So on this scale, you can see different technical readiness level, and Materia Nova typically is in the middle between the university and the industrial, so a TRL between 2-3 that we push to 6 to 7 with industrials depending on their needs. In terms of technology, we have 3 major technology is process, material, and device. At the very early stage, Materia Nova concentrated on materials, but we found out that if we want really to transfer the innovation into the industrial world, we also need to develop a deep knowledge in processes, because of course you need to process coat or transform material. And then also in a third place, the device. We support industrials in tailor-made products, engineering and industrialization. We also manage and develop projects, because a large part of our finance come from project calls, and so we are very used to create consortium and fill in some calls. We have a unit doing the life cycle thinking, and also we have a platform for analysis and characterization, which is really a support to industrials, because thanks to our equipment, they can call on us and on an expertise to do analysis and characterization that they cannot do inside their company, because for example the equipment is very expensive. Now to concentrate on energy, because it's the subject of this exchange. We also aim to accelerate the energy transition. In fact, we are not only active in the energy, we also are very active in environment, in healthcare, but in transport, we are particularly active in energy control and efficiency, transport and storage, capturing and conversion, as well as production. And now I'm just going to concentrate on 3 major topics on which Materia Nova plays a key role in developing innovation to speed up this energy transition. So, first example or a theme on which we have put innovation is the hydrogen production. In fact, hydrogen can be used as a raw material, fuel or carrier, and as an energy storage solution. Actually, almost 96% of the world's hydrogen production is produced in a very economical way by steam methane reforming, but this is very polluting. With the rise of renewable electricity production, electrolysis is one of the most prominent technology of the moment. However, these technologies still face a few challenges. The main one being its economical viability. Materia Nova has developed the hybrid plasma technology, or plasma pyrolysis, that consists in fact in splitting the methane molecule into its component, hydrogen and solid carbon. This innovative technology does permit to use less energy if it is fed by green electricity. It has no CO2 emission, and thanks to the splitting of the methane with hydrogen and carbon, the carbon can be valorized and so permitting then to decrease the cost of production and then the net price of hydrogen. It also permits to create new economical sectors by, of course, having local hydrogen production and then generating activity also locally. A second example of activity is the conversion in synthons or e-fuels. In terms of reducing the greenhouse gases, the capture and recovery of CO2 is one of the most active areas of research. And so Materia Nova developed the plasma technology and the chemical catalysis. The fundamental idea is to activate the CO2 by plasma in an energetically efficient way in order to recover it in the form of synthon of chemical industry. For chemical industry, in building blocks for synthesis of material and thereby reducing the dependence on fossil resources. Materia Nova also proposed process to complete the biogas process. Biogas generated from the waste can be converted into high added value molecules such as acrylic acid at a lower energy cost. The acrylic acid is then transformed into polymers used in the manufacture of various objects. And the third example I wanted to speak about is the energy performance. So Materia Nova is active on various regional or European projects for energy performance, mainly in the transportation, with the development of hydrophobic or omniphobic sol gel, paints, and plasma surface treatment that permits to improve the flow with direct impact on fuel consumption, avoid tiny disturbances in the surface airflow, so we have no insect or fouling if it's a boat, and so you avoid disturbance. And also this treatment can serve as anti-corrosion protection. So the non-stick properties are generally related to the wetting or the sliding property of the surface. And so we can play on the roughness of the structure, so the topography, as well as the surface chemistry in order to generate these properties. Voilà, it was my presentation. So concerning the possible student internship at Materia Nova, of course, we are very interested to welcome international students. We feel that it can always open the mind and bring some new views, new blood, and some creativity. And so you are very welcome to contact Materia Nova, and then I put in this last slide the contact information and the emails of the research human resource responsible with Marie-Lise Ledouble, and voilà, you're welcome for your student internship demand. I don't know if there is any question and if I respected the time.
Yeah, thank you very much. Perfectly in time. We actually still have 2 minutes, but I think that we could add some minutes because the last session only has one presentation, so we have more time there. So we can steal maybe a little time. Thank you, Martine Beauvais, for your perfect presentation. Yeah, very interesting. Again, I want to encourage the audience to send some questions. I think there is a question from Luigi Redigiolio in the chat. Which material do you use for anti-corrosion protection? Material for anti-corrosion protection. Do you use such material?
Yes, of course. We are specialized in developing some sol gel, paint, and coating. So we can develop on demand. Most of the time, it's not only a coating. This is anti-corrosion. Most of the time, it's also mixed with other properties, and these surface properties can be, like we mentioned, anti-stick, but it can also have some other properties, functional properties that we can add depending on the formulation and depending on the request.
So not only anti-corrosion, but also for materials. Do you know what, or can you tell what materials you use for this corrosion? I know that one can use diamond-like carbon for hardening materials.
Really, I'm not a scientist, so I'm not going to explain the component of the coating. But of course, there is a lot of experts that can explain the component in the different coating or paints that permits to reach these properties. They are very specific, and that's no problem if you want to contact them. But it's not. I am not a scientist expertise.
So I guess that is a variety of materials, what you use. Again, you are offering internship. We have a UNIS portal for internship, where I'm sure, I didn't look for it, but I'm sure that your company is offering also the internship there. Because we want to have international internship. That is somehow an experiment. We will see how it works. So one question what I have, if there is no other question, I don't see it. You were talking about a lot of projects. You're mentioning 200 projects, and